लाइक, शेयर, सब्सक्राइब ये इस चैनल के 3 स्तंभ हैं। इन्हें दबाइए और आगे की वीडियो को एंजॉय करें।
Namaste and welcome back. In this video we are going to discuss about what is a bias, what is variance, and why is there a trade-off between them with related to machine learning and how they both came into existence in the machine learning. So let's start. Let us see how bias and variance come into existence. Okay, why we need to study them. So let me go on to some derivations and we will see how bias and variance come into the picture of machine learning. x1, x2, x3, xn are the characteristics or the predictors. Y is the response, that is the target variable, and y is equal to fx plus epsilon, and f is unknown. Okay, so what as a machine learning we do, we estimate f, that is f cap x. Okay, and something which we should note about epsilon is that it is a random error with zero mean and positive variance. So these all things are given, and what I am trying to calculate is the error. Okay, I have estimated y cap is equal to f cap x. So I have calculated that. Now I want to calculate what is the error. Now error I am trying to calculate by mean squared error term, that is expected value. E represents the expected value of y minus y cap whole square. Okay, so let us try to derive that after solving these things, what we derive. So just put in the values, that is expected value of y is fx plus epsilon minus y cap is f cap x whole square. Okay, so after that what I try to do, I try to combine the f and f cap. So expected value of f x minus f cap of x plus epsilon, and I am combining these two terms with a whole square. Now I can open this thing with a plus b whole square, that is a square plus b square plus 2ab. So that comes expected value of fx minus f cap of x whole square, that is a square, plus expected value of epsilon square, that is the b square term, plus 2 expected value of epsilon into expected value of f of x minus f cap of x. Now we have defined that random error has a zero mean. That means that the mean term would be 0. That means this term is 0. So we have left with two terms. And if you remember this equality, that variance of x is defined as expected value of x square minus expected value of x whole square. Okay, now for epsilon, if I talk about, this term is 0 because the mean is 0. So expected value of x square, that is expected value of epsilon square, is the variance term. And for this term, I can write this term as variance of this term plus expected value of this term whole square. I am just bringing this term this side and replacing the equality, nothing else. So if I put x is equal to f minus f cap, if I put there x is equal to f minus f cap, what I would get? Variance of f minus f cap is equal to expected value of f minus f cap whole square, this term, minus expected value of f minus f cap whole square. So I am just replacing that term here. So I get variance of fx minus f cap x plus expected value of fx minus f cap of x whole square, and this term is remaining, so I can write it as variance of epsilon because the mean of epsilon is 0. So this term becomes variance. Okay, this term becomes bias whole square plus variance of epsilon. Okay, so what machine learners tell, that I can make variance 0 and bias 0. Okay, because if I estimate f cap very close to f, that means variance would be 0 and bias would be always 0. So the minimum error could be variance of epsilon. Hence this term is called irreducible error because we cannot reduce it further. Okay, so here we get variance term and the bias term. This is how variance and bias get into the picture of machine learning. Okay, so the bias term indicate error due to approximating error. Let us understand some more things about bias and variance. That we have function f, but it is an unknown, we do not know about it, so we try to estimate it. Now when we try to approximate, some error is incorporated into the model, and that is called the bias. And variance is how much f cap will change if we use a different training set. That means you have a training data, you train a model and you get some error. Now if you change that training data, how the model will change, that error is counted in variance. In simple words, I will try to say that bias is error in the training set. Okay, if you train some model and you find the error in training set, it is bias, and error on the test set is variance. Okay, so let us see some example that if you train a model and this is the bias and this is the variance, if both are high, we will say, what we will say? It is not performing good on the train set, it is not performing well on the test set. That means this is a very bad model. Okay, we try to apply some of the techniques to improve the accuracy of the model. In second case, if we have a low bias and high variance, that means the model is performing good on training set and bad on the test set. So this term is also called as overfitting. Very common term in machine learning. Now we have a third case. We have a low bias and low variance. That's what we want. We want our model to perform good on the training set as well as on the test set. So this was a whole picture of what is bias and what is variance, how they are incorporated into machine learning, and what we aim onto the bias and the variance.